Hey guys, part 3, 9.4, measures of variation, part 3. We're just going to look at outliers today, those numbers that are really high or really low, and we're going to figure out how to do that mathematically. So, outliers, there is a formula to find them, okay? We still have to find our Q1, our first quartile, and our Q3, and then we also have to find our interquartile range. But then all we have to do is really just apply a formula to it. It's kind of like base times height equal area, so it's not as hard as it looks, okay? Especially if you have a calculator handy, since we're multiplying by decimals here. So if I determine my quartiles, and I determine my interquartile range of a set of data, all I have to do then to figure out if a number is an outlier in the lower half of the data, I would take the first quartile, and that's in green there, subtract 1.5, or 1 5/10, times, because there's no sign there, the interquartile range. If I did that and I applied one of the numbers in my data set to that, and it was lower than that number, then it would be considered an outlier, okay? Take a look on the right here. I have my upper half. How do I determine if there's a number that's too high in my data set? Then I take my third quartile, Q3, and I'm going to add 1.5 times what my interquartile range is. Now remember, when we're doing our order of operations, we want to do the 1 5/10 times the IQR first in both cases here. Okay? So down below, let's say we have the following data. Scroll that up a little bit for you. Where's my extend page? Oh, I don't need to yet. Okay, so let's say we have the following data. My first quartile is 20, okay? So I've determined that from a sort of set of data that I have that I didn't really show. I determined that my quartile 3 is 30 from that same set of data. Remember, the Q3 minus Q1 is our interquartile range. So once I've got those three numbers, this is really pretty easy. I have the interquartile range circled there, by the way. It's in blue and it's circled in red. Okay, 30 minus 20 is 10. Now, to determine if a number in my data set is an outlier, in the lower half, I start with Q1, 20. I subtract whatever 1 5/10 times 10 is. Okay? And then notice I'm doing that in sort of a ladder form, going vertically, which I taught you back at the beginning of the year when we were working on making sure that we did everything in order with our order of operations. So 20 minus 15 is 5. If I have a number in my data set that is lower than 5, that number would be considered an outlier. On the other side, notice I have the Q3 plus 1.5 times 10. 30 plus 15 is 45. So if I looked at my original set of data and I had a number that was greater than 45, that number would be considered an outlier. Okay? And then down below I kind of explained it in words. Any number lower than 5 or higher than 45 would be an outlier. The reason for determining this, other than causing you pain and anguish and frustration, is we want to make sure we're using the right measure of center. So when we have an outlier, we really don't want to use the mean, okay? We really want to use the median because it's going to be a better measure of center if we're looking for the middle of the data, okay? So why outliers? That is it. To figure out, do I use mean or should I use median? Okay? We'll talk more about mean, median, mode, and which is the best choice in another video. Talk to you guys soon. Have a great night.